Hi everyone, welcome to this video talking about the volume of a pyramid and a cone. So we know how to find the volume of a prism already. We find the area of the base and we multiply by the height. If we were to do that for a pyramid, we'd get the same answer. But do we take up the same amount of space for a pyramid as we do a prism? I know that if I were filling this with ice cream, I would definitely want to fill my prism with ice cream versus my pyramid. The pyramid does not take up the same amount of space as a prism does. So we need to change our formula a little bit. But how? How many pyramids does it take to fill up a prism? And that's what I'm going to show you today. I have a cone, see how it comes to a point, and a cylinder. They have the same base and the same height. So if I were to keep the formula the same, I would get the same volume. But I don't want to get the same volume because the cone does not take up the same amount of space as the cylinder does. So I want you to make a prediction. How many cones of water will it take to fill up my cylinder here? Let's see. So I have some water here. This is one cone of water. Filled about here. Let's go again, part 2. This is my second cone of water. Still not quite full, but getting there. Let's try another one. My third cone of water. Filled perfectly to the top. So it takes 3 cones of water to fill a cylinder. So what we're going to see is whenever we find the volume of a cone or a pyramid, we have to divide by 3 because it takes 3 of these to fill up a prism of its same dimensions. So since it took 3 cones to fill up the cylinder, we know that to find the volume of a pyramid or a cone, after we find the area of the base and multiply by the height, we have to divide by 3. Because the amount of water in a cone is a third of the amount of water that a cylinder can fill up. And that is the same for a pyramid to a prism. So let's try this. In A, I first have to start by identifying my base and find the area. My base is a square. To find the area of a square, I do base times height. So 10 times 10 gives me an area of my base of 100 feet squared. Step 2, I multiply the area of my base by the height of the pyramid, which gives me 1,200 feet cubed. But this is not the volume of the pyramid. This would be the volume of a prism with the same dimensions. So in order to find the volume of my pyramid, I divide this by 3. And I get 400 feet cubed. So we are doing the same process of finding the area of the base and multiplying by the height, but we have to divide by 3 since the amount of space inside of a pyramid or a cone is a third of what it would be inside a prism or a cylinder. Let's try this again. In B, my base is a circle, and to find the area of a circle, we do pi times the radius squared, and the radius is 10. 10 squared is 100. So the area of my base is 100 pi inches squared. Step 2 is we need to multiply the area of the base by the height of the cone. We don't know what the height of the cone is though. They only give us the slant height. So we are going to treat this like a right triangle. And if I know 2 sides of a right triangle and I need to find the third, I can use Pythagorean theorem. So h squared plus 10 squared equals 12 squared. 10 squared is 100, and 12 squared is 144. In order to get h by itself, I need to subtract 100 to both sides. And lastly, to get rid of the square, I square root both sides. And I get that the height of my cone is 6.63 inches. So that is what I'm going to multiply by the area of my base, which gives me 663 pi. And then my last step, since this is a cone, I need to divide by 3. So my volume is 221 pi inches cubed. So make sure when you are finding volume that you use the real height of the pyramid or the cone, not the slant height. And let's try one more. A hexagonal pyramid with base edge of 8 centimeters and a height of 12 centimeters. This height is referring to the height of the pyramid, so we are going to save that for later. Right now I have to worry about finding the area of my hexagon. In order to find the area of a hexagon, we split it up into triangles, and I'm going to have 6 triangles for my 6 sides. Since this base edge is 8, I know that half of it is 4, and I need to find the height of each triangle. In order to do that, I'm going to start by finding that angle measure. So 360 degrees divided by 6 for my 6 triangles gives me 60 degrees. But then since I only want half of it, I'm dividing by 2, which gives me 30 degrees. I am now going to label opposite, adjacent, and a hypotenuse. So opposite, adjacent, and hypotenuse. It looks like I have opposite and adjacent, which would be tangent. So tangent of 30 is equal to opposite over adjacent, so 4 over h. And then I cross multiply. 4 times 1 is 4, which is equal to h times the tangent of 30. In order to get h by itself, I need to divide by the tangent of 30. Plugging this into my calculator, 4 divided by the tangent of 30 is 6.93. And now I'm ready to find the area of this triangle. To find the area of a triangle, I use base times height divided by 2. So my base is 8 and my height is 6.93. Divided by 2 gets me 27.72. But this is just one triangle out of 6 for my hexagon. So I have to multiply this by 6 to get my entire hexagon area, which would be 166.32. That was only step 1, finding the area of the base. Step 2, I multiply the area of my base times the height, which gives me 1,995.84. And step 3, since this is a pyramid, I divide by 3. And I will get my final volume is 665.28 centimeters cubed. So finding the volume is not much different for a pyramid than it is for a prism. We still are finding the area of one base and multiplying by the height, but if it's a pyramid, we have to divide by 3. And something you can say to remember that, if it's a prism, let it be. If it's a pyramid, divide by 3. Hopefully that helps. Let me know if you have any questions, and I will see you in class.